Now that we've investigated the behavior of the 3 bridges provided in the homework file, it's time to design our own. To do so, you should first begin by making a careful drawing of your bridge, labeling all of the nodes and elements, and calculating the coordinates in x and y space of each of the nodes. I've already done that, and I'm going to input a design of a fairly simple king post truss bridge, just to illustrate the steps needed to create a working model. We need to begin with the geometry menu and the define node option. Our bridge will span from the 0, 0 point, 480 inches, or 40 feet to the right in the positive x direction. The first node that we define by entering coordinates at the bottom of the screen is at 0, 0, and we must enter a 0 for the z coordinate. We click apply, and a node appears at that point. Next, we'll define a node at the other end of the bridge. Its x-coordinate is 480 inches, its y-coordinate is 0, and its z-coordinate is also 0. When we apply that, we see a node appear at those coordinates. A king post bridge is relatively simple and needs only 2 other nodes to be defined. I don't need to go back to the geometry menu each time I define a new node, but can simply enter new coordinates at the bottom of the screen. I'm going to place one node at the middle of the bridge at 240 inches and leave the y and z coordinates unchanged. By clicking apply, I cause that node to appear. I'll now enter the 4th node's coordinates by giving a y coordinate of 40 inches in the vertical direction and click apply, and that node now appears. Looking at the placement of that node, it's actually a little bit lower than I would like. So I'm going to go to the geometry menu, choose the move node option, select that new node, and prescribe a vertical or y direction displacement or delta of another 40 inches. When I click apply, we see that node move vertically. I now need to define elements. From the geometry menu, I select define element. And at the bottom of the screen, mastan is asking me to select 2 nodes, node I and node J, and then click apply to establish the element geometry. I'm going to do that for all of the elements needed to create the king post truss, clicking apply after each pair of nodes that I select. It's very important to use elements to connect adjacent nodes. For example, it would not be correct to connect node 26 all the way to node 27, bypassing node 28. That would cause an unstable structure error when you went to run the analysis. I'll continue defining elements rather. Clicking apply after each one. And finally, I put the king post into the structure. Those, in fact, are all of the elements that are required to define a king post truss. The next thing I must do is tell mastan what the material and cross-section properties are of the members making up this truss. From the Properties menu, I select Attach Section, and in this model, since I only have one set of section properties, I can simply select the All button, highlighting all of the elements in the model, and click Apply. I've thereby attached the section number 1 properties to all of the elements in the model. Under the Properties menu, I select Attach Material. Again, since we have only one material, steel, in this model, we can choose All and Apply. And at this point, I've told mastan what section properties and what material properties to use when analyzing my new design. The next thing we need to do is define the fixities, or support conditions. I'm going to put a pin support at the left end of the bridge and a roller support at the right end of the bridge. When I choose Define Fixities, 6 checkboxes appear at the bottom of the screen. To define a pin support, I want to restrain displacements in the x and y direction. So I select those 2 checkboxes, select the node to which I want to apply those conditions, and then click Apply. The red arrows appear indicating fixed displacements in the x and y directions. To put a roller support condition into the model, I want to restrain only the y displacement. So I'll uncheck the x box, unselect the node which I had previously applied boundary conditions to, select the node at the right end of the bridge, and click Apply. Now a red arrow appears only in the vertical direction, indicating a roller condition that restrains motion in the vertical or Y direction, but not in the horizontal or X direction. The final part of setting up the model is to define forces. Under the Define Forces menu item under Conditions. Because I have only one node in between the left support and the right support, I need to apply all 30 kips to this node. I enter the number -30 into the PY box at the bottom of the screen, select this node at the center of the bridge, and click Apply. A green arrow appears, indicating a downward force of 30 kips. If I had more than one node along the deck of the bridge, the bottom chord of the bridge, I would need to divide that 30 kips evenly into individual point forces acting at each one of those nodes. For example, in the bridge above the one I've just designed, there are 3 nodes in the interior of the bridge, and each of them has a load of 10 kips applied to it. My bridge is now simple but fully defined. I can go to the Analysis menu, choose First Order Elastic, make sure that Planar Frame is selected, and click Apply. If I do so, and if I've defined the model correctly, I should get a Success Analysis Complete message. I can now look at results. Under Results, Diagrams, Deflected Shape, I choose Apply, and I see the deflected shape of my structure in comparison to the deflected shapes of the other structures. A gross inspection of these diagrams indicates that my structure isn't performing that well, and I might want to go back and revise the design in some meaningful way. For the purposes of this demonstration, though, I think I'm done. To complete the assignment, what you'll do is go back and repeat the steps of finding maximum tensile and compressive and bending moment forces, maximum nodal displacements, and weights, but now you'll do it for your design in addition to the 3 bridges provided in the input file. Once you've done that, you can make comparisons between the 3 bridges that we provided and your own design. That's all for now.